prepared by Nur Idina Amalia, Kao Jing Tong, Noor Mahira, and Atira Akila. VTOL drones. Introduction, Research and Design. A vertical takeoff and landing VTOL aircraft is one that can hover, take off and land vertically without relying on a runway. Electric and hybrid electric vertical takeoff and landing aircraft, or eVTOLs, are being developed in the quest for fully autonomous personal air vehicles, PAVs. Vertical takeoff and landing VTOL aircraft include fixed-wing aircraft that can hover, take off and land vertically, as well as helicopters and other aircraft with powered rotors, such as tilt rotors. Some VTOL aircraft can operate in other modes as well, such as CTOL, STOL, and/or STOVL. To take off or land vertically, the powerful exhaust streams from a jet engine can be directed downward as well as backward, and their direction can be changed in mid-flight. This allows fixed-wing aircraft such as the Harrier or the F-35B to take off vertically, fly forward, stop in mid-air, back up and land vertically. VTOL can also take off and land like a normal airplane. Example, the first urban airport flight drones opened in UK on November 2021 partnered up with Hyundai. Munich Airport International has teamed up with Urban Airport to create eVTOL ground infrastructure and airport operation that will allow electric air taxis to take off and land vertically. Pre-planning consideration. Data on airspace infrastructure and non-aviation areas of airport land use are collected. The data include an inventory of existing physical plant, including an assessment of its condition and useful life, as well as other relevant items such as land use surrounding the airport, financial data on airport operation, community social and demographic data. Forecasting to aid in planning. Forecasting tools and concepts such as geographic considerations that will influence the quantity of flying vehicle usage. An overly optimistic projection may result in premature investment expenses and higher than necessary operational costs. Financial control and framework. Capital cost, currency required, funding source. Operational cost, revenue source, financial control. Site evaluation and selection, the location of possible areas. Factors influencing airport location, taxiways must avoid landing and takeoff paths that are over landfills and other areas that are prime bird habitats. Airfield, dimensions, strength, eVTOL qualities, design and capacity of airfields. Apron layout, stand site, parking, service and hangar aprons, holding bays. Security and apron accommodation. Air and ground navigational and traffic control aids, visual aids, radio navigation aids and their buildings, demarcation of critical areas, air traffic services search and resume services, apron control communications. Cargo facilities, sitting, building function and type, apron, facility requirements, access parking, inspection and control. Airport operations and support facilities, administration and maintenance, medical facilities, VTOL fuel station, generating stations, water supply and sanitation, forecasting services, aircrew buildings, aircraft repair, rescue firefighting, and general aviation facilities. Sustainability. To reduce the environmental effect of air travel, we aspire to develop feasible aircraft with net zero operational emissions. Here are some examples. Proposed final VTOL, helipods, landing spaces that accommodate helicopters and various other VTOL aircraft or rotorcraft, minimum approach obstruction clearance, design minimum width of approach and departure path, multi-landing. Passenger building, the closer a passenger is to a takeoff or landing location, the more time can be saved. If a landing location is too far away from the origin or destination, the passenger may not have enough time to make a UAM journey worthwhile. Our vertiport designs for urban, suburban, and waterfront sites. Each of these models include landing pads, charging station, and terminal for passengers awaiting their journey. Safety and security. Our airports will include emergency at-risk, fire safety plans, and contingencies for adverse weather. Each flying vehicles would have to meet or exceed the safety standards already in place for traditional aircraft. Refueling. We install the necessary physical hardware and then pay utilities for electricity drawn at extremely high rates, such as electric batteries then requiring fast charging or battery swapping, hybrid gas and electric and hydrogen. Flying vehicles. The flying vehicles may climb and drop vertically or at any desired angle, as well as fly forward, sideways, or backwards. It has a low turning speed in other axes and can fly from zero velocity circling to its maximum rate longitudinally. It can take off and land extremely tiny spaces if necessary, in an area just a few times the diameter of its main rotor. If this occurs, the rotor immediately disconnects from the engine, and according to the concept of auto-rotation, flying vehicles will proceed to resolve in such a way that the flying vehicles may land safely. Here are some example videos we found on YouTube. Marketing mix. We have 4 P's in the marketing mix, which is product, price, place, and promotion. And here are the examples and definitions for the 4 P's.